Okay.
Take it away, Siddhartha.
Hey. Hi. So I'm Siddhartha. I'm also a PhD student in Computer Science here at Brown. I'm here to talk about teaching programming to novices, and given the number of talks today about it already, I think we can all agree that teaching people to program is hard.
And we love doing it.
Yes. Okay, a little louder. Yep, maybe this is better. Okay, so the first thing we've noticed is that students often misunderstand an assignment and solve the wrong problem. This is universal in programming classes. Immediately, they get frustrated, it wastes a lot of time, and from the instructor's perspective, it detracts from the learning objective. You know, everybody gets a little frustrated, but when they're solving the wrong problem, they really get frustrated. So there's this sort of time-tested pedagogical method of saying, well, state the problem in your own words. Just say it back to me, and then you'll really get it. The problem here is that novice programmers do not have the words. So if I asked you to tell me what median, implement a function that gives me the median of a list, these are the words. Novice programmers do not have these words, So then what do? Well, we think about things that could potentially be, words that novice programmers have, and things we want them to be able, and vocabularies we want them to have. We've spoken a lot about examples today. Why not examples? This, a novice programmer can say, and it gives you some idea of median. They can give me some input and some output, and sorry, can you hear me?
Yeah.
Yeah. Okay. And they can, and now we can go and look at their idea of the problem. They can look at, and it's a lot more digestible. So the problem here is that even though students can write this, we want to give them actionable feedback. So I want to talk about the idea of an executable example. We give students this idea of a wheat. We call wheat for, reasons I don't need to explain. It's a little complicated, but effectively it's the correct solution. And the correct solution keeps them on track. Every time they write an example, they can run the example against the correct solution, and it tells them whether they're right or wrong, and that kind of keeps them on track. So if a student, wrote something that was a little off track, the wheat says no. And whether that's a typo, a type error, or they just really misunderstood the problem. So sad enough. Now, the student knows that they're on the right path, right? But do we know that they're not on the wrong path? Consider this test suite the student's written, right? Students cannot write too many tests, but they'll write some. They all pass the wheat. Can they go and solve the problem? Yes?
I can't help but notice that all the arrays in the examples you presented are already been sorted, so a perfectly valid inference from this is that the median is simply the middle element of the array.
I'm getting that. That's great. Yeah. So to your point, is the student ready to go and write median now? Have they demonstrated to us that they understand median? In Hazel's talk, it was mentioned that there were tests that you hope would reasonably cover the data definition, right? Well, over here we want tests that reasonably cover the problem. So aside from students telling us here that they are not on the wrong track, none of these are wrong, we want to make sure they're on the right track. So that's why I want to talk about, if you think about it, like you said, these examples are true for median, mean, and mode. We don't really know if the student has really got the idea different for each of these. So this is why I want to introduce this idea of buggies. And buggies are a set of buggy implementations that correspond to student misconceptions. The idea is that the student is able to check the validity and thoroughness of the implementation with a combination of of the examples with wheats and buggies. So we implemented this in an IDE, in an intro class of Brown, that lets students do this. So this is the test week we've been talking about. Students write the test and they're told, your tests are valid, they're consistent with median, but look, we want you to also demonstrate that it's not the buggies. So if a student were to add a test that shows that median is not mean, well, now they've caught a buggy. They show that median is not mode, they've got another one. And now we're helping them refine that idea of what the problem is that they're solving, and they're demonstrating that to us in a very interactive way. But choosing these buggies is hard. We don't want too many of them. We tried giving students many of them, and they really get sucked into the gamification aspect of this. They spend so long trying to catch buggies that they never go and write the median.
You made something more fun than real programming.
Right, exactly. We like examples. Yeah, and then what we don't also want to do is just give them a bunch of mutated versions of the wheat, of the oracle. Because imagine if it was a program that was median except for if the input was all ones. Well, that's pretty frustrating to catch. They get caught in the gamification loop. They never get anywhere, and that doesn't really help. So it really needs to align to misconceptions students have. A few effective buggies, a lot better than lots of mutated buggies, and 4 seems like a good number, right? So how do we actually get them? Well, traditionally, they've sort of been artisanally handcrafted by Sriram.
Why not just look at last year's homework and see what they got wrong?
And that's exactly what we're getting to.
Just living in the future over there.
I know, right? But no, it's a good incentive. The question is what they got wrong, how. So traditionally, the instructor goes and observes the class, consults with course staff. Instructors think they have a pretty good idea of what the students are going to get wrong. I mean, some people have taught this course for years and years, and then they go and they write it down, right? But as you noticed, students get these things wrong, and why not look at them, right? So let's look at these bad examples. Some of these, the last 2, fail the wheat, right? These are the same 3 we've been working with. Does anybody want to take a guess at what does the student really think they're solving here for?
The middle.
Right. Great. Should we do another one?
Yes.
All right. How about here? These 2 are incorrect.
Second element.
Second element, that's a good guess. Yeah, pretty much. They just choose the left median. If it's even numbered, they're like, all right, I'll just take the one on the left. And left median, for example, is something that instructors never thought someone would get wrong. Think about it. Instructors have blind spots, but we're seeing it in the data. So the idea here is that we want to class source our buggies. Every time an example fails a week, it could correspond to a misunderstanding student has. I mean, it doesn't always have to, like we've seen earlier. There are typos, there are type errors, but a lot of them are also student misconceptions. We take a sample of those and we use them to inform selection of the buggies for next time. So how does this work in practice? We applied this methodology to 2 programming problems in an introduction to programming course. One of them was a collaborative filtering problem, and the other one was document similarity. And 2 experts went and classified all of the buggies. So,
all the failures.
Oh, sorry, all the failures. I'm speaking a lot today. I'm going to show you the misconceptions, but we pretty much found for the first one that experts thought there'd be 7 broad classes of misconceptions. There were 17. Only one thing predicted by experts actually showed up in the data. So, yeah.
The 17, they come from classifying the errors,
Yes.
and that is by one set of experts. And then there's another set of experts that they thought about the Nile problem and came up with 7 problems.
Yeah, so this is the instructor. This is me and Ben.
You're the experts.
Yes.
No, it comes from the data.
Well,
No,
from
it
the
comes
data.
from YouTube.
No.
When you
There's
decided-
an interpretation step of the student failures.
Yeah.
Right? There are different experts interpreting, but they're also using a methodology to make sure that they're not.
So we have a very strict coding rubric, and I can talk about like the intercoder agreement stuff.
You're
But
interpreting it straight from the data.
straight from the data, right? You like we did for left, median, or middle, right? It often suggests it's a pretty straightforward. We saw the same thing for the other assignment too, right? Experts thought there would be sort of 5 broad class. Yeah. Sorry.
So is 4 a good number to actually present?
It's a yes. So I think the number is a function of the problem, right? But the broad rule of thumb is that you don't want so many that you fall into this gamification trap. You want enough that it's the spread of the problem, but not so many that people get caught trying to catch them.
I would have said something slightly different. I think you want all of the ones that are commonly popping up and skip the uncommon ones.
Sure.
And maybe with a cutoff of some number.
Yeah.
So I guess I'm a little confused about what this Venn diagram is telling me. Should I read it as the failures in the real world should be more finely separated out than what the experts predicted?
Yes, so it's actually the sets of misconceptions that were seen versus that were predicted to be seen.
And just that they were better categorized in smaller units in the real world, or that the actual expectations were very different?
The expectations were very different, and so the overlap here is the only times the expectation matched with the ground truth in some sense.
So the experts thought of 3 problems that didn't actually show up.
Yeah, 3 problems that didn't show up. There were 9 problems that showed up in 9 misconceptions of the problem that were never even thought of by experts that showed up. Sorry. Yeah.
So for Docdiff, then, would you want closer to 4 or closer to 11 buckets?
So, what I'm kind of being a little glib about here is, as Sriram said, the frequencies of each. I think 5 for Docdiff is kind of the good number. I can talk a little bit later about actually evaluating the quality of an entire suite of these buggies to see whether they're good or bad. Sorry.
For the years that you crowdsourced this data from,
Mhm.
did students have access to the weeks and chaff?
They did.
Okay. So
Yeah.
could it be that helps them avoid the misconceptions on the left that the experts come up with?
The misconceptions are weak failures, so they haven't even got to the chaffs, the buggies. And that's why they're called wheats. You separate the wheats from the chaff. Sorry.
No, but it goes on this extraordinarily well. I think, so the point is you wrote an example, you failed, right?
Yeah.
Okay, so you did get feedback, but the point is, before you got feedback, you had already made the failure. So we're looking at your failure, right? So the existence of this tool, Examplar as it's called, the existence of the tool doesn't make a difference because you had to have written that buggy example in the first place.
The only thing that matters that you have the wheat in the first place, but you still reflected your understanding of the problem at some slice of time, and we've been able to glean something from
We
it.
projected it there.
Yeah. Sorry.
So I was wondering if it would be useful to have an adaptive set of buggies that you present to students where they say, I think this, and you say, I think I see where you're going.
Oh, funny you should say that.
Yeah.
Let's go on.
So, well, right before we get there, I just wanted to...
This is the future prediction road.
Yes, right? So, the first thing I just wanted to make sure all of us kind of get out of this is we have words that students can use to describe their understanding of a problem. We can give them feedback.
Sorry, Siddhartha, can I just make a point?
Yeah.
If they can't even write the example, they have a bigger problem, right? So we're not saying they have the words, but it's a baseline we expect them to have. And if they don't have that, then there's some other issues going on. So that's really maybe a slight refinement.
Okay, that's that. Yeah, I think for a student who has some broad understanding of the problem, examples are a great set of words for them to refine their understanding of the problem. It's also, by making those examples executable, we can give them real-time automated feedback. And we can make the feedback really useful by looking at the data and seeing what the class does. Now let's talk about what we can do with this data. One thing we did is start generating hints. So what we could do is take examples. This is from Docdiff. This is a real hint that showed up. Look at the programs that failed the wheat. We can give people hints and then compare it to our sort of this inventory we've created of common misconceptions, and then zoom in on part of the assignment that deals with that and nudge students in the right direction. There's lots of other things we can do. We can adaptively, the future work would be adaptively nudging the chat so you can have almost a personalized experience, in some sense, your misconceptions, with the caveat that you don't want to have an infinite set of chaffs building because you don't want to over-gamify.
So why do we get a hint here?
So we get a hint here because this failure matched some previous set of misconceptions we've seen. In this case, we can the misconception we saw in previous years was matched by this. It was reflected in a buggy, and it passed the buggy.
I think it's confusing. You say it matched a set of misconceptions.
Okay. Yeah,
you wouldn't give a hint if it matched a set.
Right. Sorry.
Okay. So let's be crisp about that.
Okay. Yeah. It matched a misconception we've seen earlier. That misconception was added to the set of buggies. So in real time, we can see, does it pass the buggy? If it passes the buggy and fails the wheat, we know what the student's misconception was, and we can give them a hint that is actionable. That's kind of most of what I had. There's a lot of future work here, though.
So could you have sort of, when you're sort of giving them the hints, you do a few master buggies, but there's, more than 4 misconceptions that students are making. Could you have sort of extra buggies that aren't shown to the student except when it matches?
Yeah,
great question.
Yeah, that's a great question. That is ideally what we'd like to have. There's sort of some...
The suggestion was you want to minimize the number of buggies you show because students will get overwhelmed trying to catch them. But if they match one of them, but we have many more misconceptions we know about. So if there's a weak failure, we can also check it against these other hidden things, right? And if it matches one of those, we can say, you seem to have the following misunderstanding. So we can still generate a hint. So we could have 10 or 12 misconceptions that generate hints, but only 4 that they need to catch.
Yeah, so generally, yes, the answer is we do need to be mindful of the sort of the 3-second rule here, where if it takes long enough to run this example against all the buggies to see which ones are matched, students get very frustrated. So there's, again, you have to still choose. You could choose a larger set, but you want to make sure it's not too big.
The idea here is we can have more than what is visually shown.
Absolutely.
There's always trade-offs.
Yeah.
Is your ultimate goal with this to hire fewer TAs?
So I think there's this is a really good question. So you could see this being sold as a TA on demand, right? But it's not quite. There's a difference between being a tutor and a system that gives feedback. As an instructor, when a student asks you a question, you typically don't say, the assignment says, blah. You hopefully try to...
sometimes.
So you want to phrase it
Spend
differently.
more time teaching if you will.
Yeah. It's like, what if I told you the answer was in the syllabus? Page 3, paragraph 2. Everybody asks the same question every time.
Well, so the idea is that, yeah, in some sense you have a tighter feedback loop for a very common class of misconceptions. But then other things, you can basically use your TA time more usefully.
If I wanted to be less cynical, I could say rather than hiring less TAs, you might have the same amount of TAs doing more interesting work.
Right.
Ideally, but...
Yeah, the less TAs who have to remind people that overlap and dot product are the same, or that mean and median are different.
So another question. I feel like the work that you put into discovering the buggies is a really interesting thing to like deeply understand the problem. If you can understand the problem so much that you can identify which are the good buggies, then you really understand that problem. So in some ways, like, if we're trying to get students to really understand Docdiff, maybe we can assign them to create the buggies.
So this is a really good question. So we did think of this, and we actually ran a study.
For people who didn't hear it.
Oh, sorry. The question was if to classify the misconceptions and build buggies, you have to really understand the problem. So why not have students do that to really understand, for example, Docdiff? So we did try this. We ran a study where we had people who had taken the course or had TA'd the course at some point, were TAs, and asked them to do the same classification. And we compared it to expert classification. Wasn't quite as good. We have I'm happy to talk about that later, but the problem is that there is some degree of expertise required to sort of curate the set of buggies. The other step of extracting misconceptions from buggies is something that we believe can be automated, and you can kind of throw this at, depending on the domain, at a SAT solver or some kind of subproperty decomposition, and actually like extract semantic meaning from the failures and not have to involve people at all.
I think there's a better answer here, which is that Jay's idea is a terrible idea. Right? They're struggling to write one function, and now we're going to ask them to write like.
I don't think this is something for students. I feel like this is something that I'm imagining experts doing. That like.
Yeah.
So if I'm writing a type checker, and I'm a big brain person writing type checkers, I will understand type checkers better if I can write bad type checkers.
Yeah, for sure.
So this might be a way for me to think about doing a really hard thing to deliberately make bad versions in test cases.
Absolutely.
Yeah.
Like all books should have the bad versions and explain why the bad versions are bad, and then move the students over to the good versions. So yes.
Isn't there psychology that people will sometimes remember the bad version instead, though?
We can have a long conversation about this. It turns out there's a generally widely held belief amongst educators that you should never show students the bad things because then they will remember that and then they won't learn from that. That's what they'll remember. And it turns out that is not true.
That is bullshit. Sorry.
I guess
yeah.
I had a different question.
Oh, sorry.
So my understanding, a buggy is a program.
Yes.
Okay. A program produces an answer given a set of input.
Mm-hmm.
So I wonder if, for example, the median, you could say if their program produces an answer that is not in the list and is not, I don't know how you're resolving even lists, but say the mean of any two things in the list, then they're just doing something wild. So do you want a different language for writing buggies that allows sets of answers or answer classification rather than a specific answer just to match using equality? Right.
So this is a very good question, and it does kind of depend on the domain. For example, we're working on doing this for the Forge language that Tim just presented. And in Forge, first of all, execution isn't quite this. The model of execution is different. So sometimes instead of points in a space, you can think of these things as properties, and then you can do things like that. In something like this, this intuition that there could be like kind of a little bit of shift in the spaces is really correct. In fact, like in practice, we don't give people one wheat, but it might be a set of wheats because our assignments themselves might not be like perfectly, specified. My sense is that you still want to give people very fixed buggies because you want them to be able to catch them. And in fact, you don't want to make it too hard for them to catch them either. Does that make sense?
Yeah,
I wonder if this.
Can we take this offline because I
Yeah,
don't
sure.
understand what you're saying better, and I think it's not of interest to everybody necessarily, but I really care.
Sure.
Oh, sorry.
I wonder if the presence of some of the buggies is because the instructor explained things poorly in the lecture, or because the problem was written poorly.
Yeah, absolutely.
For sure, for sure.
Oh, absolutely. So I think there are two things we can do there, right? One is by giving, in hints, by just giving slices of the assignment, we're kind of controlling for that language. It might just be bad. And the occurrence of these misconceptions later are a feedback tool for instructors. So an instructor could go back and say, oh, students really did fail the wheats a bunch, thinking that median was mode. And that's feedback to the instructor as well.
Yeah, so have you thought at all about this outside of the context of pedagogy? Specifically, like, this reminds me of, there's a game called Understand, where you essentially need to draw a line, but it doesn't tell you the rules. You just have to figure it out, and it has a set of rules
So
that you have to get progressively closer
the
to.
sort of two answers there. Outside of pedagogy would be amazing, though we do need to find scenarios where you can start with some executable conception of correctness, or some specification of correctness. I would love to talk about that. Outside of that, in a pedagogical setting, to understand things from scratch, I think that's what Sriram would love this to be finally. That's such a constructivist approach to what people will learn, but it would cause so much frustration among students. Figure out.
We're running out of time. Stop the shot. Quick, last 2 to 3 minutes.
I have already asked so many questions.
Do you think it's feasible for buggies to be automatically generated?
I think so within certain bounds.
We will know in a year.
Yeah.
Sam.
So you have this nice quote from the assignment here. I have 2 questions about that. One, do you have to do that manually?
Yes.
And 2, have you thought about trying to connect it back to the actual place where the assignment appears, so that students can see the connection between, because teaching people to read the assignment is an important part of the curriculum.
So there's actually a little more here, right? There's actually a reason why there's the actual text from the assignment, because we were trying to do a control study, right? So we didn't want to add new text here that was not in the assignment. We wanted to control for that variable. Arguably, 2 different things you can do. One is write different text over here, because clearly maybe they read the text and it wasn't working, so maybe just yelling at them louder, maybe doing it in like blink tag is not going to help anything. But the other one, of course, as you point out, is maybe just highlight the text part of the assignment. So I'll say, if you just read the assignment, you would have discovered this for yourself. Last question. Last one. Quick. Okay, we're done.
Thank you.
Thank you.